For anyone who's joining, we'll get started in just a few minutes. We got people just 1 or 2 minutes to hop in and get situated here. So there are folks that are starting to trickle in. We're going to cover a lot of Swift and iOS today, and not really touch on any Turbo native stuff, but I think it's going to be a really good intro for all of that. So we're going to start in just maybe just 1 more minute or so. So give some folks some time to pop in. I'll cut off the music and we'll get started. Okay, let's dive in. So today we're going to cover Swift and iOS in a very broad brushstroke, kind of a crash course sense. And the content will be structured mostly for folks familiar with Ruby and Rails. We're drawing a lot of parallels and connections between those 2 languages and frameworks. So if you're familiar with those, you should be totally comfortable here. I'm going to walk through a bunch of stuff on Swift, and essentially, optionals, protocols, extensions, that kind of stuff. We're going to be dive into a little bit of iOS in how code is structured, how to navigate Xcode, and then we will wrap up with just a quick demo of how to get a simulator up and running and off to the races there. So I don't think it'll take more than an hour, hopefully even less. And before we dive into all of that, quick introduction. My name is Joe Mazzalotti. I blog on Mazzalotti.com, and there you can find a lot of information on Turbo Native, on Ruby on Rails, on iOS, and if you're also interested in attending any sort of workshop on this type of stuff, my email address is all over there. So pop in and let me know. Okay, so let's dive in. On my screen here, I have a IRB console, an interactive Ruby shell on the left, and a Swift playground on the right. So we're going to be drawing comparisons between the 2 as we walk through this. So the first thing that we're going to talk about is in Swift, like how do you even get started? So I have Xcode running here. I'm running Xcode 14.3. You can download it from the App Store or from apple.com. I don't think you need a developer account anymore, so it should be totally free. When you get into Xcode, you can do File, New, Playground, and then you can give it a name. I've called mine My Playground, which is just the default, and this is what it looks like. You're given some sample code, but we're going to work with a plain blank slate here. So let's dive into the content here. In Ruby is dynamically typed, so we can say something like x equals 1. We can say x equals 2. X is now equal to 2, and we can even say x equals Joe. And no matter what we do to this variable x, it always assumes the type that we assign it to. So if we did something like x.class, we'll notice that x is a string. If we assign it back to 1 and do x.class, we'll notice that x is an integer. That is the class that it maintains. In Swift, however, we're statically typed. So if we do something like var x equals 1, and we can do x equals 2, we Command Shift Enter there is to get the output over on the right, or we can click this little arrow. Again, Command Shift Enter to run that. We can't assign x a string. because X cannot assign value type string to type int. So we're trying to assign a string, but this variable here, X, was defined as an integer. If I option click or alt click on this, you'll see that var X is of type int. So we can't ever change a type of something. So if we ever wanted to do a string, we'd have to actually assign a new variable. And now this variable would be of type string. It's inferred from the initial value that we give it. We can also type it by typing something like this. That's essentially saying, forget what's over on the right. I want this to be a string. This is really useful for things like doubles. We can have a double, but give it an integer. This variable will be assigned a double. So allocate the memory for a double there, versus assigning an X is an integer, which is inferred. You'll notice here that we're using var also. Var is very similar to JavaScript var, or let, sorry. And in Ruby, we don't ever really think about constants as much. We can define a constant equals, food, something like that, but we can always reassign a constant. Yeah, we get a warning, but constants aren't actually constants in Ruby. In Swift over on the right here, if I do let, get rid of this, we're going to say let name equals Joe, and I try to assign it something else, like my son's name, we'll see that here that you cannot assign a value name to a let constant, because it's a constant. I can change let to var to make it mutable. If I fix that, it'll change let here to var. I try to use lets as much as possible, same as like in JavaScript where you want to use const as much as possible, because we want to make sure that we keep our state as tightly scoped and as predictable as possible there. So in Ruby, that gives us a quick rundown of like how variables are typed and assigned. I'm going to clear out the left over here and talk about optionals for a second. In Ruby, we can say that X equals 1 again. We can also just assign nil to it. And we don't really have a difference. The type of class, again, is always inferred by the last object that was assigned to it. So X now is a nil class. We can do things like 2s on it because that is defined on nil. But if we try to do something like X plus 1, plus isn't defined on nil. It's going to get kind of weird. I'm sure you've seen, undefined method, whatever, for nil class in your Rails or your Ruby code before, and that's mostly because we have no way of knowing that this variable can't be null or nil. However, in Swift, we have to be explicit about that. So let's say we create a dictionary, and a dictionary is a hash in Ruby world. Let's say for breakfast we had eggs, and then for lunch we're going to have a sandwich. If I try to access that dictionary and I try to grab breakfast, and I run that, I can option click on breakfast and see that we have type string, but we have a question mark at the end. That question mark means that this variable is optional. It means that could be nil. It might be, it might not be. We know that it's not. We print out breakfast. We're going to see over down in the bottom that it's an optional type eggs. We know that it's there, but the compiler doesn't. So if we tried to do something like, I had 2 eggs for breakfast, or sorry, if I had 2 eggs for breakfast, and I try to run that, I'm going to get an error here because we don't know what to do with an optional value. It's essentially saying that breakfast could be nil, and how do we add something to nil? Well, we can't. So we have to do there are a couple of ways of fixing that, and they usually involve unsafe unwrapping or force unwrapping, nil coalescing, or if let unwrapping. So the easiest one, the one that's going to give you the fastest time to market, but also the most dangerous, is to just throw a bang on the end there. We've now force unwrapped this variable. You can see on the right we have 2x eggs as we expected. We've made breakfast, if we pull it out, force unwrapped. We pull it out like that and we check the type, we'll see that it is now a string. There's no more question mark at the end like we had for breakfast. However, the problem here is that if we change something, if we try to grab, let's say, a snack out of the dictionary, and we throw an exclamation point at the end, and we try to run this, our application is going to crash. You'll see that this playground couldn't even run and throw an error. It was a runtime error that the app crashed. Unexpectedly found nil unwrapping an optional value. This is essentially a null pointer exception in Objective-C. We've tried to find a slice of memory that it doesn't have anything in it, or that wasn't allocated yet for us in Objective-C or C terms. This is really bad. This is very dangerous because your app will entirely crash. It'll get sent to the home screen if you're running an iOS app, and it will look, and because it is a bug. So a better way to do this is to, we can do two things here. We can null coalesce or nil coalesce, which essentially means question mark, nothing. Question mark is how we would, sorry, parentheses. It's the nil coalescing operator. It's very similar to something like if you do over on the left here in Ruby, nil or foo. It's going to say that nil is falsy, so it's going to pop over to foo. In Swift, though, question mark is different than something like 1 or 2. This is actually or, and this is nil coalescing. This is only to be used if this variable is nil. It can only be used in optionals as well. So we can't even do something like dictionary or foo, because dictionary can never be nil. So that's one way of unwrapping safely. The other option is if let. So we can do something like if let, let's do eggs here equals breakfast, sorry, equals dictionary breakfast. I'm going to get rid of this up here. We can now say 2x plus breakfast. And I can run that, and we'll see that over on the right, we have 2x eggs. This is essentially saying if let, it's grabbing the right side of the equal sign, and if it's not nil, assigning it over here. What that means is that we are assigning a variable that is no longer optional for us. We've unwrapped that safely. This code on down here is only going to run if this is not nil. So a really nice way of getting into optional unwrapping. What we can also do here is if we had assigned breakfast as a variable up here, we can actually use the shorthand introduced in Swift 5.3 and just say if let breakfast. So that's going to just optionally unwrap for us, and we're going to be able to work with that down later inside of this block here. Okay, so we've now talked about optionals. We've talked about strongly typed, statically typed. Let's dive a little bit more into how Ruby's implicit duck typing is different from Swift's strongly explicit typing. Let's clear out this over here. Over on the left, I'm also going to clear out with Command K. Let's say we have a class called dog, and it has a method called make note or say hi, and it's going to just return woof. We can say dog.new.say hi. We're just going to say woof. Let's do another one with cat. Cat.class cat def say hi meow, and we can do cat.new.say hi. So we've created what would normally in Ruby be called a duck type. Both of these classes respond to the method say hi. So if we throw both of them in an array, we can now iterate over them and say, nope, that's Swift syntax. So let's clear that out. We're going to do dog.new and cat.new. Each grab the first parameter that was sent in and call say hi on them. And those don't return anything, so it's returning the instance. So if we map over that, we're going to get woof and meow. You'll notice that no matter what we threw in that array, we were always able to just call say hi. There was no compiler error against us saying, oh, cat doesn't respond to that or whatever. If we threw something else in there, maybe a, the integer 1, we're going to get an error at runtime when we try to call say hi on that integer. That doesn't exist. This is more closely to how, so this is duck typing. It looks like a duck, it behaves like a duck, it's probably a duck. They all respond to say hi, cat and dog, so we can just call say hi on them. On Swift, however, if we do the same thing, so let's create a dog class, call the function say hi, and this is going to return a string. I have to be explicit about the return type here as well. Return woof, and then class cat. Same thing, return a string, return cat. Down here we can do cat, say hi, and we can do dog, say hi. So just like before, Command Shift Enter, we have woof, we have we have cat, the Pokemon, we have meow. But if we tried to throw these in an array called maybe animals and throw a dog and a cat in there, the compiler is not going to know what to do with this. It's going to say that heterogeneous collection literal cannot be inferred. It's saying you have two different types. They're not related at all. This is not a homogeneous collection. I don't know what to consider this as a type. So the only way to type that in this scenario is to call them an array of any, which essentially we've lost all typing. We've assumed that any old object or any old thing can be thrown in there. And it doesn't really buy us much, because if we try to do animals dot, let's say first, don't have any properties, because any doesn't have anything defined on it. There's nothing that exists on any. It's like a generic super class, a protocol type thing that just doesn't define anything. It's just a container object almost. So what we want to do here is define up at the top a protocol called animal. A protocol is an interface that only defines the API, the external API of a class or a struct. In this case, we're going to say that if you're an animal, you must respond to the say hi function that always returns a string. Notice how I'm not implementing this function. I'm just defining the API. I'm defining the interface for it. Now, if we grab this class dog and we say that it implements animal, or this cat and we say that it implements animal, I run that and these all respond to say hi, so that's okay. But let's add another one. Let's add a mouse. Mouse on its own is no problem. But if we say that the mouse implements animal, we're going to get a compiler error. It's going to say that the mouse does not conform to the protocol animal. It does not have the say hi function defined on it. So let's let Xcode fix this for us. We can click fix. We're going to get the implementation or the signature done for us. All we have to do here is return, what does the mouse say? Squeak? Say squeak. 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 Now we have a mouse, a cat, and a dog that all respond to say hi, but we've made that explicit by saying they implement the animal protocol. Now down here, we no longer have to type as any. We can type as an array of animals. What this means is that when we iterate over animals, we do for each, we grab our animal, we can now call animal.sayHi. And now every time, let's print it out so we can use the result. We'll get down at the bottom, we have our woof, we have our meow, we can even add in our mouse to get our squeak. Now that all of these objects or all of these classes conform to a protocol, we're able to call that method on it, because the compiler knows that no matter what's in here, they all have to conform to animal. If I try to throw an integer in there, like 1, it's going to tell me that the type is ambiguous without more context. It's saying to us that there's something weird about this array. Not everyone is an animal, because 1 is not an animal, so it doesn't know what to do. Let's get rid of that, run our application again, and we'll see that we're printing out our woof, our meow, and our squeak. One more thing that I want to touch on with how protocols, like we have up here, and implementing protocols work is that there's something called an extension. I could have defined dog like this. This is saying that dog is just an empty class. It doesn't do anything. But I can move the implementation of the animal protocol to an extension. Extensions are very similar to how you might monkey patch in Rails. They add functionality on things that you own or don't own, third party, first party, whatever. But it adds functionality in a way that doesn't modify the state internal. And what it means is that we can add functionality by implementing our say hi function in the extension. What that gives us is two things. One, it allows us for neater code organization. If dog also implements the canine protocol, we could also have that down here instead of also in the dog class. We can have it, separate our protocol implementations via extensions. And it also means that if we don't know where the dog file is located because it's a third party, we can write this extension anywhere in our code and start to work with that. This is super powerful because you think about things like extending on an integer. We can have functions like, is 42, and we can say self equals 42, and now we can do something like 42 dot is, or 30 is 42. And you'll see here that when we run that, func needs to return a bool, we get a new functionality that was added on top of integer, which we don't define anywhere. That is part of the the standard lib, and we can now add functionality on top of it. So really, really powerful for adding these convenience functions or ways to make your code a little bit more legible without having to actually worry about monkey patching or diving in. And the order of operations here is that you can't overwrite a function, so they're usually pretty safe to use because of the way that Swift is strongly typed. Okay, that wraps up what I want to talk about for Swift. Let's move on to iOS. So I have another Xcode project that's right here. And this is a brand new Xcode project with everything that you don't need removed. So I did this by doing file new project in Xcode, doing an iOS app, hitting next. And then I also changed I switched SwiftUI from storyboard if that was selected, and I gave it a product name. I work in SwiftUI a lot, but I find that the scaffolding for the application is much easier to use a storyboard interface and that to work with Turbo Native, which is where I'm working 90% of the time. So once you have that, you're going to get a lot of boilerplate. You're going to get an app delegate, a scene delegate. You can remove almost all of that code, which is really nice. So let's dive into Xcode and how to navigate it in terms of how do you get around, how do things work. Over on the left, you have the project navigator. You can switch between Git changes, your errors, your test suite. You can toggle these with command 1 through 9. And if you don't see this over on the right, command 0 will toggle opening that and closing that, which is really nice. I like to do command 1 for the file explorer. And over on the right, if you hold down option and do 0, you're going to toggle over on the, I believe it's properties, the inspector, the file history, or quick help. I don't really use this very often, so I usually close it pretty quickly. When we're in Xcode, if we single click on one of these, it's going to open it. If we double click on it, it will keep it open no matter what we open after that. And what is probably the most important thing is Command Shift O for open quickly. That's Command Shift O. We can fuzzy find anything in our app and also read through any of the documentation that matches that. And by hitting Enter, we can then open up. So this is some Objective-C code from the iOS 16.4 simulator. So really helpful when you have a lot of files. It will match. Also, will match function names. So see here, scene will connect. It's actually this function you're seeing right behind here. So really helpful if you're looking for the name of a function and don't remember it in your own code. So let's dive into how a app is structured, the hierarchy. Every app's going to have an app delegate, kind of like old, throwback to C days or Objective-C even. It's going to have a main function. It's going to say this is the entry point to the application. You don't need to implement anything anymore in here, which is really nice. You just have to define the class as an app delegate, is conforms to that UI responder protocol, this application delegate protocol. Normally, you would do things like registering for push notifications. When a user clicks yes on your push notification thing, you'll implement some code in here. But until you get there, and until you start messing with this, you actually don't need anything in this file, which is really nice. Scene delegate is what gets called every time a window opens on your app. Well, how do you have more than one window open? On the iPhone, you can never have more than one window, to my knowledge. You have a single window, a single scene. On an iPad or a macOS SwiftUI app, you might have two scenes side by side in a split view. Or if you have a document editing app, you might have multiple tiled windows, multiple scenes. In iOS, this code right here, which is pretty much what they give you when you do file a new project, is good enough to get started, and we don't need to modify it much more. So let's run our app. I'm going to click this button right here. It's going to launch a new simulator, or a new instance of a simulator. I'm running on an iPhone 14 Pro, running iOS 16.0. You can see up at the top. And we have a white screen with nothing on it. This is by intention. We haven't done anything besides set the background color to white. So let's just pull this over a tiny bit so we can see. Let's change the background color to system green, which I think is one of the less offensive colors. And we'll see that it's green. Cool, we've set the background color, not that exciting. We actually want to add a view controller to this. Like on Rails, MVC framework. On iOS, we have the MVC framework as well, which are mostly dealing with modal view controller. There's very little distinction between views and controllers in iOS. Massive view controllers is a big symptom on iOS as well as as there's in Rails, but you kind of also put the view in there too. So we're only going to actually create a view controller and not even have a model here. So what we can do here is change this back to white, and we're going to grab our window and grab the root view controller property and set it to a UI view controller. UI view controller is the option, click here to get the documentation from Apple, an object that manages the view hierarchy. It's the core building block of iOS applications UI. We're going to have a view controller for every kind of screen, pretty much. They're usually synonymous. We'll have one for the index page. We'll also have one for the show page. It's almost as if Rails took their view and shoved all the controller logic into it. So you can imagine we're going to have a lot of them. If I run this, we're going to be back to that white screen. This view controller doesn't have anything in it. It doesn't do anything. So it's not going to show anything. So what we're going to do is subclass that view controller called myViewController. And we're going to override the function called viewDidLoad. ViewDidLoad gets called when the view is loaded. It means that we are ready to start manipulating the view. It means that we're ready to start adding things to the view. So first thing we want to do is called super viewDidLoad to make sure that any setup of UI view controller gets implemented. And now we can start messing with this. We can start adding adding buttons. Let's add a label, which is a text field. And let's say that label dot text equals hello world. We're going to add the label to the view, get it on the screen. We're going to tell the label to size. We're also going to make sure that the label is sized to fit. So based on the text that's in it, we want to change the frame of it. And then finally, we're going to say that the label dot center, so the X and Y coordinate, is equal to the view center. This is going to put that right in the middle of the screen. Finally, instead of assigning the root view controller to this generic one, we're going to assign it to my view controller. You'll see here that we have that set up. Run the app one more time with Command R, and we'll see that we have our first label. We now have a label on the screen that says hello world. And not a ton of code, but probably way more than you're used to with doing something like HTML and the Rails controller, because we don't have any logic here. It's the way of iOS. Okay, so we have a label. We want to make this a little bit more interactive, though. So let's change that label to instead to be a button to print out something into the logs down here when it's clicked. Okay, so we're going to change our label. We're going to now create a button equals UI button. We're going to give it a type of system. That gives us that nice hover and fade out effect automatically for free. It'll make it look more iOS-y. We're going to set the title to tap me for the normal control state. I know, bizarre. What this means is essentially show the text on the button to read tap me in all scenarios. There's different states that normal enum could be highlighted or pressed or all this other options that I don't really care about for 90% of the time. We pretty much just want to get in there and say, okay, for all states, have the text tap me. Do the same thing here. We do button.size to fit, and then we'll add the button and we'll center the button. Command R to run that again. And we have a button now that says tap me that has our nice hover, and clicking has our nice hover effect. Doesn't do anything though. So let's add a callback, a click handler, if you will, to make sure that we are printing out to the console down on the bottom when we click that. To do that, we're going to add a target action. Target action is borrowed from the days of Objective-C. It's a way of dispatching messages dynamically to different objects. We tell that button, when you're clicked, who do you want to tell a message to and what message do you want to send to it? So self is going to be my view controller. That's who's going to receive the message. Selector, this is a fancy way of getting a compile type safe method, is going to say, button was tapped, was a method we have to define. And then when we're going to call it is touch up inside. Touch up inside is a weird way of saying they click the button. Is not helping me here. There we are. Touch up event in the control where the finger is inside the bounds. Very technical way of saying that you've pressed the button, and when you released your finger, you are still inside the bounds of it. You haven't dragged off of it. Essentially means you tapped it or you clicked it. We have a compiler error, though, that's saying that this is not defined. What is button was tapped? Let's create a function. Button was tapped and try to build one more time. This time, though, we're going to get a different error and says that it's not exposed to Objective-C. We're in Swift world right now. Everything that we've written so far is Swift. There's no Objective-C connection. It's a quick fix. All we have to do is add Objective-C to the front of that. It added this right here, and now we have exposed this method to our Objective-C runtime. We can now print out button was tapped. Run this and watch down in the logs as I tap this over and over and get our logs. We've now wired up this button with a few more lines of code. We've done the same thing here like we did with the label. We've centered it the same way, but we've added a target action and we've added that callback, kind of like a click handler in JavaScript or Stimulus. We've kind of wired it up to do something. We're going to touch on two more things here. We're going to touch on how to push a new screen, kind of like navigation flows. And we're going to also talk about presentation. So on iOS, I'm going to open up the Settings app. And this here that I'm looking at is a navigation controller. It handles the pushing and navigating between screens. If I dive in, if I click screen time, it crashes. Let's try general. If I click general, you'll see that it slid something across the screen. Let's turn on slow animations with debug slow animations here and try one more time. You'll see how it slides in. We're pushing a screen onto the stack, onto the navigation stack. We can go deeper. We can go into the keyboard. We can go infinitely deeper here. We can go back down to hardware keyboard. All of these are different UI view controllers sitting on top of a navigation controller. We can go back by clicking this or popping an instance off the stack. This is really useful for any sort of base navigation of your app. It's the standard. It's if you go from the index page to the show page, from the show page to some other show page. To do this, to wire ourselves up, we have to do two things. We have to get an instance of a navigation controller, and we have to start pushing controllers onto it. So back up here, we have our view controller, and we set that as the root. We're going to throw one more step in there called navigation controller. And we're going to give it a root view controller of our view controller. This means that we're going to have a nav controller, and the first view that you see is going to be this view controller. We're going to set our root view controller of the window here to our navigation controller. And when we run this, we have the exact same thing. We don't have any difference. Nothing looks or has to have changed. It's because iOS 15 and above started hiding that beautiful navigation bar if there's no title. We can fix that by backing our view.load load by saying self.title equals my view controller. We've set the title of a view controller, and the navigation controller knows that if it's displaying a view controller and it has a title, to display that up in the top. You'll see that right here. Cool. So we now have wrapped this in a navigation controller, and we want to put a new screen on the stack, so to speak. So let's create a second view controller. We'll call it second view controller. Inherits from UI view controller. And on our view.load here, we're going to create that label again. Size to fit. Add the subview. And do label center equals view.center. So now we have an instant or a class of second view controller that we can start messing with. How do we get that onto the stack? In our button callback, instead of printing out, we're going to grab a reference to our navigation controller. This is defined on every UI view controller. It's an optional property, and it means we have to optional chain it just like we would in Ruby with an ampersand. And every view controller has a reference to that to know which one it's contained in. It might be nil though. But we know that we have one, so we're going to optional chain and call push. Push view controller does exactly what you might expect. It's going to push a new controller onto the stack. So we're going to push an instance of second view controller, and we're going to pass true for animated to get that nice animation across the screen. Command R to run it. To turn on slow animations here, I'm going to click tap me. And we have a very odd looking animation. What's going on there? Why is it so gray and then white, and you can kind of like see it under the hood? By default, all views are transparent. So now we have a transparent view being pushed on top of a transparent view. So when we get to that point right before the other one falls out of memory, we're seeing the whole thing underneath. The quick fix there is that right after we set our title, or right after we call view.load, we can grab our view.background color and set it to white on both our my view controller and on second view controller. Now we should have a much more expected, cleaner animation there, even when it's slowed down. You can even notice how my view controller becomes the back button, which is really nice. Cool. Let's turn off slow animations, and we're going to wrap up with one more way. We're going to talk about presenting screens, or modals. So back into our settings example, we've dug into pushing things onto the stack, going left to right, diving deeper. If we want to break out from that flow, maybe present a form or ask the user a question, a modal presentation is the standard on iOS. So if I click this sign into iPhone, you'll see that it presented from the bottom. It's slid up from the bottom. This is called a modal presentation, modal navigation controller. There's a lot of names for it, but essentially it's a sheet that comes up that is breaking the flow of what you're currently working in. It's changing contexts. To do this, instead of navigation controller push, we're going to just call present. Present view controller is going to present this on top of itself. We no longer need a navigation controller. We're not even going to reference it. The my view controller instance is going to have a reference to second view controller right on top of it. I'm going to run this and we'll see how this now animates up from the bottom, just like we'd expect. What I will normally do for these is that I'll create a modal navigation. So if that second view controller needs to do any sort of like pushing or diving deeper into a flow, it'll already be wrapped in a navigation controller. It won't change the UI at all. This looks exactly the same until we add a title. Now, when we present that second view controller, we're going to have that navigation bar and the title set up at the top, like we'd expect before, as you can see peeking under the hood there from my view controller. Okay, so that wraps up what I wanted to cover for kind of like a crash course into Swift, a crash course into iOS, some basic navigation. We covered all the stuff that we covered today was optionals. We covered protocols, strongly typed versus statically typed versus duck typing. We covered presenting screens, Xcode layout, navigating Xcode. So a fair amount of stuff in just 40 minutes there. This should be a really good start to how you can dive into a Turbo Native project, especially with something like Jumpstart Pro, or following one of my tutorials on building Turbo iOS apps. If you want to check out the code for this, you can get it from my GitHub repo, Joe Mazzalotti, and then Swift Crash Course is the Swift one, and then iOS Crash Course is the Xcode project that we worked through on that last thing. If you are interested in hearing more about Turbo Native or more about iOS, check out my blog over there, mazzalotti.com. I post pretty frequently on how to integrate Ruby on Rails apps into iOS, mostly through Turbo Native. And I just announced a new workshop that's coming up in May to give people kind of a crash course like this, but on Turbo Native that will be a group of like 20 folks and way more interactive. So that's on sale now. It's expected to sell out pretty soon as well. So take a peek. And if you have any questions, I'll drop my email in the chat. Don't hesitate to reach out if you want to get in touch or need help with the project or just want to chat. So thank you again. Thank you for joining, and I will see everyone next time.